arithmetic mean, geometric mean, and harmonic mean. My name is Abefe. I am a YouTuber, a content creator, and a full-time tutor, and welcome to my learning space. In the last two videos, we've talked about the concept of the arithmetic mean and the geometric mean, and for today, our attention is on the harmonic mean, and that begs the question, what is the harmonic mean? So in the mathematical terms, the harmonic mean is simply the size of the data set divided by the sum of the inverse of the individual variables present in that data set. So let me actually give us a bit of an example right here. So let us assume we have three variables. We have variables x1, x2, and x3, and we want to get the harmonic mean of this data set. All we have to do is to have the sample size, which is 3, divided by the inverse of each of the variables. So that means we have a 3 divided by 1 over x1 plus 1 over x2 plus 1 over x3, where 1 over x1 represents the inverse of the first variable x1, 1 over x2 represents the inverse of the second variable x2, and 1 over x3 represents the inverse of the third variable x3. Just like we did for the concept of arithmetic mean and geometric mean, we can also get the harmonic mean of our dataset if our dataset is in the raw form, or it is actually sorted based on score and also sorted based on class. We are going to be solving questions on that when we get to the worksheet. So we can now ask ourselves the question, when do we use the harmonic mean? So if you can remember vividly, I said that the concept of arithmetic mean is best used when we need to get the average of independent variables and variables that actually grows linearly, or variables that actually changes linearly. And we use the concept of the geometric mean when we have dependent variables and variables that actually grows exponentially. Your geometric mean also work best with percentages and fraction. And for our harmonic mean, the harmonic mean is actually best used when we want to measure the average rate of change. So by rates of change, I'm talking about variables that change over a period of time. So we're talking about speed, we're talking about velocity, we're talking about the time value of money. So those variables that actually change as a result of the change in time are best used with harmonic mean. So that means if you want to actually get the average speed of a car or the average velocity of a car, it makes sense to use the concept of the harmonic mean rather than the concept of the geometric mean or the arithmetic mean. So that being said, it's time for us to go into our worksheets to actually learn how we can get the harmonic mean for our data sets in its raw form, our data sets based on class, and our data sets based on score. Let's go there. So the essence of this video is to actually let us learn how to get the harmonic mean of a data set, and if you take a closer look, you will notice that this was the same data set that is a raw data that we used to get the arithmetic mean, the geometric mean, and we are also now using it for harmonic mean. And that is because by the end of the harmonic mean video, I want us to compare the arithmetic mean to the geometric mean to the harmonic mean and tell me the one that has the largest value and the one that has the least value. So this is our data set, and this data set is in its raw form. So that means that it was extracted directly either from the population or from the sample, and no sorting of such was done. So the formula for the harmonic mean whenever we have our data set in this format is going to be n, which represents the size of the data set, divided this is not really clear. All right, so divided by 1 over x1 plus 1 over x2 plus 1 over x3 till we get to 1 over xn. So that means that we have each of the variables. X1 represents one of the variables, x2 represents the second variable, x3 represents the third variable, till we get to the nth variable. So in this case of ours, our sample size n is equals to 6. So that means we have 6 data sets. So we'll substitute the parameters into the formula. We have that the harmonic mean is equals to, so the sample size, or the size of our data set rather, is equals to 6 divided by 1 over 2 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 2 plus 1 over 3. So I'm going to be substituting all of this into my calculator. So we have HM is equals to 6 divided by, so let's put all of this into my calculator. So we have 1 over 2 plus 1 over 2 plus 1 over 2 plus 1 over 3 rather, plus 1 over 4 plus 1 over 2 plus 1 over 3. And the answer we got is actually 29 divided by 12. So this is same thing as saying 6 divided by. So let's keep our answer in decimal form. So we have a 2.416. So when we do the math with our calculator, so 6 divided by 2.416, and that gives us 2.48. So the value of the harmonic mean is actually 2.48 to 2 decimal place. So our question says that Billis wants to know how much time on average does his colleague in school spends in the library in a week. He took a random survey by asking students how much time they spend reading and got the following data. So we have 2, 3, 2, 4, 3, 3 down to 4. So the question says that the timings were measured in hours and we're supposed to calculate the harmonic mean or the harmonic average time the colleague of Billy spends reading in a day. So the first step is in solving this question is to create a frequency distribution table for our data set, and we've actually done this when we were using the same data sets to get the value of the arithmetic mean and the geometric mean. So that should not be an issue getting the frequency distribution. So let's draw the horizontal line right here, and we have the vertical line right here. So according to the table we had in the last few videos, we have x to be here, which represents the variable of interest, which is time right here, and we have f to be frequency. So we have this to be 2, we have this to be 3, we have this to be 4, we have this to be 5, we have this to be 6, and we have this to be we have this to be 7. So 2 occurred 3 times in this data set of ours, 3 occurred 5 times, 4 occurred 6 times, 5 occurred 3 times, 6 occurred 1 time, and 7 occurred 2 times. So the formula for the harmonic mean, rather, when we have a frequency, a data set grouped based on score, is going to be, we have this to be summation f, which represents the size of the data set, and there's just a little tweak right here. So we have f1 divided by x1 plus f2 divided by x2 plus f3 divided by x3 till we get to fn divided by xn. So in this case of ours, we are going to be having our summation f to be equals to 20. So that is 3 plus 5 plus 6 plus 3 plus 1 plus 2 gives us 20. So that means our harmonic mean is going to be equals to 20 divided by, so we have our f1 to be equals to 3 divided by 2 plus we have f2 to be equals to 5 divided by 3 plus we have the third to be equals to 6 divided by 4 plus we have this to be 3 divided by 5, we have this to be 1 divided by 6, and we have this to be 2 divided by 7. So I'm going to be using a calculator directly to work on everything I have at the denominator. So after slotting all of this into my calculator, I have the harmonic mean. We have this to be 20 divided by, we have 1201 divided by 210. So, and when we slot all of this into my calculator to get the final answer, so we have 20 divided by that, and that gives us 4200 divided by 1201, and if we keep this to decimal, we have the answer to be 3.50. So the harmonic mean of our data set is actually going to be 3.50, approximated to 2 decimal places. So let's get the harmonic mean when we have our data set sorted based on class. So let's go there. And here's our question. It says that you grew 50 baby carrots using special soil. You dig them up and measure their length to the nearest millimeter, and we have the group of results. So we have length and we have frequency. So we are supposed to get the harmonic mean of this data set. So the first step is to actually extract out the table. That is, we're supposed to reconstruct it. So we are going to come right here. So we have the horizontal line like we used to do, and then we have one of those lines. We have this right here. We also have this right here, and we can just have one more in case of necessity. So let's just have this. So let's try to complete the table. So we have our x to be here, we have our frequency to be here. We are going to be needing the middle class, which is xm. So that means that we're just going to have like a 150 to 154. We have 155 to 159. So let's quickly rush through the filling of the table. So the XM actually represents the middle class, and for us to get the middle class, we have to take the average of the classes we have for each of the class. So that is for 150 to 154, which is a class. So the middle class is going to be 150 plus 154 divided by 2, and the answer we have is going to be 152. 159 plus 155 rather plus 159 divided by 2, that gives us 157, and we do the rest for the remaining classes. So we have our middle class right here. So it's time for us to get the formula for getting the harmonic mean when we have our data sets grouped based on class. So the formula is for the harmonic mean, it's almost like the one we did earlier. We have our summation f right here. Instead of having individual variables, we're going to be having middle class. So we have our f1 divided by x m1 plus we have f2 divided by x m2 plus f3 divided by x m3. So we do that till we get to fn divided by x mn. That is the last variable we have in our data set. So in this case of ours, it's going to be a very long one, so we have to be careful. So that means that our harmonic mean, so we need to get the sum of the frequency, and the sum of the frequency is 5 plus 2 plus 6 plus 8 plus 9 plus 11 plus 6 plus 3. That gives us 50. So we have 50 divided, it's going to be a long line. Okay, so we have 5 divided by 152 plus we have 2 divided by 157 plus 6 divided by 162 plus 8 divided by 167 plus 9 divided by 172 plus 11 divided by 177 plus 6 divided by 182 and plus 3 divided by 187. So I would be using my calculator to work on everything I have at the numerator, at the denominator rather. So we have 50 divided by, so let's use our calculator to do that. And our answer in decimal place is going to be 0.294. Let's give that in 3 decimal place. So the harmonic mean HM is going to be 50 divided by 0.294, and we have our answer to 2 decimal place to be 170.04 millimeter. So this is the value of the average, the harmonic mean rather, in 2 decimal place. So what I want us to do is to compare the arithmetic mean of this data set, the geometric mean of this data set, and the harmonic mean of this data set, and tell me which is the smallest and which is the largest. The same applies to the raw data set and the data sets when sorted based on score. If you enjoyed this video and you learned something new in this video, I would really appreciate if you can subscribe to this YouTube channel and switch on notifications to get notified when I upload new videos, which I do at least 2 times in a week. Thanks for making it to the end of the video. We'll see you in the next video. Bye for now.